Hi guys, today we're going to cover section 3.5 inverse functions. If you look at the number 1 under things to know, you'll notice that there is a definition called the one-to-one function. And one-to-one function is different than the function that we normally talk about. If you remember, when we first talk about a regular function, that means as long as it passes the vertical line test, which means I could have something like this, and this is a function because it passes the vertical line test, right? But the issue in this case is you could have two different x values, and that give you the same y value. So you could have two different x values, and that have the same y value. Okay, so this function, even though it's a function, it is not one-to-one because one-to-one means you cannot have the same numbers. Okay, the same x value cannot happen, same y values cannot happen. Okay, so graphically, what that means is that the only way you have a one-to-one function, it's a function that passes both vertical line test and horizontal line test. So for example, this graph right here is a one-to-one function because it passes the vertical line test. It also passes the horizontal line test. Okay, so that's the easiest way to think about one-to-one function, is that graphically it passes both vertical line test and horizontal line test, and algebraically that just means that you cannot have the same x value or the same y value being used for a function. Okay, now the rest of the one is pretty straightforward. We'll talk about more the part C and D, the finding the inverse and the verified inverse. Those are pretty algebra heavy, so we'll definitely work a few of those questions. But let's go ahead and move on. Okay, let's see if I can. Oops, I'm gonna go back and plain white. Okay, so number 2, it says, are these functions one-to-one? And they give you a big hint here is you should know whether the parent function are one-to-one or not. So if you look at part A, you have a f of x is negative 2x plus 5 quantity squared minus 6. This is a quadratic function. Okay, so quadratic means what? Quadratic means it's either opening down or opening up. So this is definitely not one-to-one. Because it failed the horizontal line test. Okay. Part B. You got f of x equal negative 4 absolute value 3 minus x plus 2. This is an absolute value function, which you know typically is a V shape or upside down V shape. Again, fail. It fails the horizontal line test. Okay, so part B is not a one-to-one function. Now part C. Part C, you have f of x is negative square root of negative x minus 5 plus 3. Okay, this is a square root function. Square root function, typically, if you have y equals square root of x, it looks like this. A square root function is a one-to-one function because if you try to draw a vertical line or a horizontal line, you only cross the graph one time. Okay, so this right here is a one-to-one function. Now, you can definitely try to graph it in your graphing calculator to see what it looks like. So I think you'll find out that it does pass the vertical line test and horizontal line test. Okay. Part D. This is if you graph this, or if you try to solve it, either way, you'll realize that it crosses the graph at 2, 5, and -5. Okay, which means this graph, if you try to punch in the calculator, the graph looks more like this. And this is a fail. It fails the horizontal line test again. Okay. So for some of these, hopefully you have the parent function memorized. So when you look at it, it should give you a good idea how things are shaped. Instead of trying to graph it with a graphing calculator. Okay, a goal is that if you can recognize it, and it'll make things a little easier, a little faster, and you'll be able to remember other stuff. All right, so let's go ahead. I'm gonna move on to the next problem. Okay, so number 3, if you look at it, now I'm gonna have to go back to number 3, wrong one, sorry. There you go. Number 3, what you see here is this is called a hyperbola. It looks like two parabolas, facing towards each other. Why not? Are these 1-to-1? Answer is no. Not 1-to-1. It fails the vertical line test. You also fail the horizontal line test. Right, this one's a double whammy. It doesn't work. This graph right here, part B, this one, it passed the vertical line test everywhere. It also passed the horizontal line test everywhere. This is a 1-to-1 function. Alright, this again, right, it passes all the vertical lines and all the horizontal lines. Wait, does it? Did I just say that? No! It failed the horizontal line test. This fails the horizontal line test. So this is not 1-to-1. You thought I was sleeping, weren't you? Alright, next. This is looks like the vertical line test works. Horizontal line test works. 1, 2, 1. Okay. Alright, so being able to tell whether a graph is 1-to-1 or not is fairly straightforward. You just got to make sure you pass both vertical line test and horizontal line test. Okay, next. Alright, given a graph of the original function f of x, find the graph of the inverse function. So, by definition, inverse, the graph of inverse function is the mirror image of the original function over the line y equal x. Okay, so if I graph the line y equal x, which looks kind of like this, the mirror image of it is the inverse function. So what do we do? Well, this is where the trick is. When you're reflecting, right, the mirror image of the original function over the line y equal x, all you have to do is switch x and y. So for example, this point 0, -2 now becomes -2, 0. This point right here, 3, 0, it now becomes 0, 3. And this right here is our inverse. Pretty straightforward. If you want to graph the inverse function from the original function, all you have to do is switch the x and y because the definition. Okay, next. This one's a little tougher, so let's go ahead and for part B is a curve, right? So it's a little tougher, so let's go ahead and label some points. This right here is 0, 1. This is 1, 2, 2, 4, 5, 6, 7, 8, 5, 8. Wait, 3, 8, sorry. This is 3, 8, not 5, 8. Okay, and this is kind of like maybe a -1, 1/2 or so. Alright, so let me just draw my line. Y equal x. Alright, here we go. 3, 8 means 8, 3. 2, 4 means 4, 2. 1, 2 means 2, 1. 0, 1 means 1, 0. -1, 1/2 means 1/2 -1. And since if you look at the original function seem to flatten out along the x-axis, so that means my inverse function tend to flatten out over towards the y-axis. And there you go. Okay. Alright, so again, this one's going to be pretty straightforward. Straight lines are easier to figure out. So this is 0, 3. This is 2, -1. Having these 2 points, I can figure out what the inverse is. 0, 3 means I have 3, 0. 2, -1 means -1 and 2. Connect the dot. And putting the line down for the y equal to x, it will look kind of like this. You can definitely tell that's like a mirror image. Okay. All right. So that's the graphing part. The graphing part is for most part people are okay with the graphing part. The algebra part is the one that's going to give people a little bit of issue, but we will work through those. Okay. All right. All right, for number 5, we're gonna have to figure out the inverse function based on the function that's given. So this is the steps that I always follow. So algebraic steps to find the inverse function. That's an f to the negative 1, looks like. So what I always do is, step 1, change f of x to y. Second, I will switch x and y. 3, solve for y. And 4, change y to the inverse notation. Okay. So this is what I always do. So let's go ahead and check out part A. F of x equal 4x minus 1. So we change the f of x to y. And then we switch x and y. And now we solve for y. Now solve for y is the hardest part. Because depending on what kind of function you have, right, you're not always going to get linear. You could get rational, you could get radical, you could get later log function, exponential. So, yeah, step 3 is always the hardest part. But let's go ahead and solve for y. So this is x plus 1 is 4y. So y is x plus 1, x plus 1 over 4. So once we're done solving for y, and we change it over to the inverse function. Okay. And feel free to graph this. If you graph this on Desmos or on the your graphing calculator, you'll see that they definitely are mirror images of each other over the line y equal x. Okay. All right. Some additional notes. Okay. So yeah, but this is a step for any problem that asks you to solve for inverse function algebraically. Okay. Now talk about the domain and the range. Right, remember the step that switch the x and y, right? So if you're talking about the domain and range, right? So after they switch, so if because of the switching, the domain and range of the original function is gonna be the opposite. Or I should say switch for inverse. So the domain of the inverse function is the range of original. And you can guess the range of the inverse function is what? The domain of original. Okay, this is very important because of the x and y switch. Their domain and range are also switched. Okay, so be very careful about that. All right, so let's go ahead and look at the next one. The next one, you have f of x equals square root of x minus 6. Okay, being a radical function, I'm going to go ahead and find the domain and range first. Now remember, a square root function means the inside under the square root has to be greater than or equal to 0. So from here, this tells me that x minus 6 has to be greater than or equal to 0. So x has to be greater than or equal to 6. the range of a square root function. Notice there is no shifting, right? There's no moving up and down, left and right. Well, there's moving left and right, but not up and down. So the range is, this is always greater than or equal to 0. Okay. Now, just make sure we're not confused. X is greater than or equal to 0. I'm going to write as an interval notation. So this is going to be 6 to positive infinity. And this y is greater than or equal to 0 is going to be 0 to positive infinity. Okay. Alright, now let's go ahead and work on the inverse. Okay. Inverse. Now, if we're just looking at based on the domain and the range, remember we said the domain of the inverse is the range of the original. So that means the domain in this case is, for the inverse, is going to be from 0 to positive infinity. The range for the range for the inverse is going to be the domain of the original, which means in this case it's going to be bracket 6 infinity. Okay. All right. Then from here, let's go ahead and find out what the actual function looks like. So f of x equals square root of x minus 6. So replace the f of x with a regular y. And now we switch x and y. And now we solve for y. Square both sides, and x squared plus 6 equal y. So our final answer is the inverse function is x squared plus 6, where the domain, where x is 0 or greater, and the range is 6 and up. Okay? Alright. I'm going to see if I can use the same page. Part C, you have f of x equal 1 over x minus 5. So in this case, we know the domain for the original. Domain is x cannot equal to 5. Now, what about the range? If you try to graph this, what you end up getting is you get a graph that looks like this. 1, 2, 3, 4, 5. So which means this is saying that the range is going to be the y value cannot equal to 0. So this is going to be from negative infinity to 0, union 0 to positive infinity. If you put this in the graphing calculator. Okay? Now again, write as a set notation. X is not equal to 5 means negative infinity to 5, union 5 to positive infinity. Okay. Alright, so which means that the inverse, the domain is going to be the range of the original, and the range is going to be the domain of the original. Okay. Alright, let's do some algebra. F of x equal 1 over x minus 5. Switch the f of x into a y. Now switch the x and y. Cross multiply, you get x times y minus 5 equal to 1. Divided by x on both sides, you get y minus 5 equal 1 over x. add 5 to both sides, you get y equal 1 over x plus 5. And you'll notice definitely x is not equal to 0, which matches our domain. Plus 5 shifts everything up 5. So I think this worked out perfectly. So a little bit of algebra, a little bit of crazy algebra, so we'll get through it. Okay? Alright. Part D. Part D, you got f of x equal cube root of x plus 2. This time I'm just gonna, if you remember the cubic function, the domain and the range are all real numbers. So from negative infinity to positive infinity. Okay, so you don't have to worry about too much about this one, about domain and range. Okay, so which means the inverse, right? Inverse just to switch. Which you still get the same anyways. That does not change at all. Alright, so here we go. F of x equal cube root of x plus 2. So which means y equal cube root of x plus 2. So x equal cube root of y plus 2. Solving for y, cube both sides. X cubed is y plus 2. So x cubed minus 2 equal to y. Inverse function of x is x cubed minus 2. Alright? Okay. Alright, last one. F of x equal x minus 3 squared minus 1. So be very careful. If you look at this one is a parabola that has a vertex at 3, negative 1, opening up. Now, be careful. This graph right here is not a one-to-one function. So, which means I have to restrict the domain meaning only look at part of the original. Okay. So the way for this one to work is that the only way I can turn this graph into a one-to-one function is if I erase half of the graph. Right? If I erase half of it, that means the other half will pass both vertical and horizontal. So that means in this case, right, we're going to erase this half right here. So which means we're only looking at the graph where x is greater than equal to 3. Because this point here is 3, negative 1. Okay. So in this case, the original function, the domain is bracket 3 to positive infinity. The range is going to be from negative 1 and up. Inverse function, the domain and the range are switched. So domain will be negative 1 to positive infinity, and the range will be from 3 to positive infinity. Alright, let's go ahead and do this. F of x equal x minus 3 squared minus 1. So switch the f of x into a y. Switch x and y. And solve. X plus 1 is y minus 3 squared. Square root both sides. You get square root of x plus 1 equal y minus 3. So needs a little bit of space. So square root of x plus 1 plus 3 is y, which means that is the inverse function. And if you try to graph the square root of x plus 1 plus 3, what ends up happening, you see it's a graph that looks like this. It's a graph that looks like that. Which I think eventually they'll cross and you'll see where the mirror image comes from. Okay, there will be times that you have to restrict the domain, and most of the time the book does give you a domain that's already restricted, so you don't have to worry about it. But I just want to make sure you know that and remember to do that sometime and check later. Okay? Alright, number 6. We need to prove that f of x and g of x are inverse of each other using composition. Alright, for number 6, we're going to verify the inverse of each other using composition. The only way for this to happen is you have to show this. You have to show that f circle g of x equal x and g circle f of x equal x. They both have to equal x or it doesn't work. So here we go, composition. Remember, f circle g of x means f of g of x. So I'm going to work on that first. And so f of x is negative 2x plus 5. G of x is x minus 5 over negative 2. So let's go ahead and do the f circle g first. So f circle g means I gotta take the g of x and plug it in. So this is f of x minus 5 over negative 2. Now, once I have f of x minus 5 equal over negative 2, so go back to function f. Whatever goes in here also goes in here. So this is now a negative 2 times x minus 5 over negative 2 plus 5. And I think this one will turn out pretty well. Negative 2 and negative 2 cancel. You get x minus 5 plus 5, which you get x. Smiley face. We're halfway through. Okay? Now, let's go ahead and look at G circle F. Remember, G circle F means G of f of x. That means I need to plug in f of x. The entire quantity, negative 2x plus 5, gets put in here. Alright, so now I have g of negative 2x plus 5. So go back and look at my function g. Again, whatever goes in here, goes in here. So this is negative 2x plus 5 minus 5 all over negative 2. Simplify the numerator first. plus 5 minus 5 cancels. So you have negative 2x over negative 2. Negative 2 and negative 2 cancel, you get x. So both compositions you get x, and so from there we can say f and g are inverses of each other. Okay. You need to do composition on this one, unfortunately. There's just no other way around it. Alright, part B. F of x is x cubed plus 4. G of x is cube root of x minus 4. So let's go ahead and do some composition. So f circle g first. F of g of x. Plug in g of x. This is f of cube root of x minus 4. Now looking at the function f, whatever goes in here goes here. So this becomes cube root of x minus 4 quantity cube plus 4. Cube and cube root cancels. You have x minus 4 plus 4, which is x. Okay. Halfway done. G circle f of x. G of f of x. Plugging f of x, you get g of x cubed plus 4. Okay. Now remember, g is the cube root. So whatever goes in here goes in here. So now I have x cubed plus 4. So it goes into cube root of x cubed plus 4 minus 4. This turned out pretty well. This is cube root of x cubed, which is x. And once you have this shown, and you have proven that f and g are inverses of each other. Okay? Part C. F of x is x squared minus 3. X is greater than or equal to 0. Notice this time they restricted the domain. Right? So they make sure the graph is 1 to 1. G of x is square root of x plus 3. So f circle g, hopefully that works. Right, here's the definition for f circle g. So f of square root of x plus 3. Plug in the square root of x plus 3 into f. You get square root of x plus 3 quantity squared minus 3. So you square and square root cancel. You get x plus 3 minus 3, which is just x. Okay, that's what we want. Sorry, that's what we want. Try again. Now let's look at G circle f. G circle f is g of f of x. So taking f of x and plug it in. So g of x squared minus 3. Now g is square root of x plus 3. So again, whatever goes in here goes here. So this is square root of x squared minus 3, quantity plus 3. Simplify, you get square root of x squared, which is x. And therefore, we get x for both answers. So g and f, they are inverse functions of each other. Okay. All right. Last problem, the story problem. The area of a circle given by a of r equal pi r squared. Okay, I think we know this one, right? Pi r squared is a circle, where a of r is the area in square units for the circle with radius r. A pet dog is tethered to a stake in the backyard. If a tether is 10 feet long, how much area does the dog have to roam using 3.144 pi? Well, right, if you think about this, the post, here's the tether, so essentially you're making a circle that is 10 feet, so area of 10 is just going to be 3.14 times 10 squared. It's 314 square feet. Okay. B. What is the inverse of A? Alright, so here we go. So in this case, let's check this out. So again, right? So we say, so A is like our Y. Let me rephrase that, sorry. A of R is like our Y and R is like our X. So what we end up having is Y equal pi X squared. Switch, we get X equal Y pi Y squared. And that means we have solve for Y, you get X over pi equal Y squared. So plus minus square root of X over pi is Y. But again, in this case, the negatives don't make any sense. So we're going to deal with positives only. So this is going to be X over pi equal inverse function of R. And just to make sure, I use the correct letters for everybody. So where the X used to be, that needs to be replaced with R as well. Okay, there we go. All right, now as regarding to the independent dependent variables, remember independent is input, dependent is output. So our original function, our independent is the radius, and our dependent output is the area. However, this time, because we have found the inverse, so that means independent and dependent, they're switched. So for our example here, the inverse A, so the A inverse of R, that actually is that's the inverse function, right? So the output for the inverse function is the input of the original, which means this is the radius. And the R, in this case, from the inverse function, is actually going to be our area. So the independent is going to be the radius. The dependent, sorry, I had it backwards. This is actually the dependent. This is the independent when it comes to the inverse function. It's a little weird, just a little bit. Part C, or number 3. If the owner wants to allow the dog 1,256 square feet of area to live and roam, how long of a tether should be used? So we're going to use the inverse function, and we're going to put in 1,256 over 3.14, where the pi is, and calculate that, and that will give us the radius. So if you calculate it, let's see, find my calculator. So you get 1256 divided by 3.14, which is roughly 400. And square root that, you get 20. So for number 3, the owner wants to allow dog 1,256 square feet of area to live and roam. The tether should be 20 feet long. Okay. Alright, so this is it for the inverse and the composition of functions dealing with inverse. So hopefully this is hopefully you can understand this fairly easily. The graphing, just remember to figure out the inverse function of the graph of inverse function, because of the x and y switch, all you gotta do is just switch the x and y. Okay, 1-to-1 functions, right, means you pass both vertical line and horizontal line tests. So any questions, feel free to find me in the forum on Facebook, on Blackboard. Or you can send me an email, whsieh@grcc.edu, 616-234-4729, or office hour. Okay, alright, good luck, and let me know if you got any questions. I'll talk to you guys later.